Let us discuss one more question from the rotational motion. The question reads like this: a tube of length L is filled completely with an incompressible liquid of mass m and closed at both the ends. The tube is then rotated in a horizontal plane about one of its ends with a uniform angular velocity omega. Find the force exerted by the liquid at the other end. Now, let us try to figure out what exactly the question says. Now, if I draw a rough diagram for this particular situation, we have a rod or a tube which is of length L. Now, about one end it is made to rotate. That is exactly what is given with an angular velocity omega. This is what is given. Now, how to find the force exerted by the liquid on the other end? Let us take one element. If I take one element of this of length dx, now what is given? Given mass of liquid, this is m, length of tube is L. So, from this what we can conclude is length L, mass is m, therefore, length of dx, what will be the mass? That is m by L into dx. Now, this element, if we consider that it is at a distance of x units from the axis of rotation, so therefore, this element will experience a centripetal force. So, therefore, dF is equal to mass of the element m r, which is x and omega square, because angular velocity is going to remain the same for all the elements. So, m is what? Mass of the element. So, m by L into dx, this is m, and x and omega square. So, writing it in the proper form, dF is equal to m by L and omega square and here x dx. This is what we have. Therefore, total force we can write as integration of dx, that is m by L and omega square integration of x dx from 0 to L. So, this will give us m by L omega square, it is x square by 2 from 0 to L. So, this gives us half of m L omega square. Now, what is so important about this? The most important fact is you will feel it is centripetal force. So, we can take it as m r omega square. Here r is the length of the tube, hence we can take it as m L omega square. But you see, if we properly analyze the situation, we are getting half of m L omega square.